Welcome to the introductory problem of the concept of linear momentum. So there is a picture on the screen and there is the problem statement, and it says a wedge of mass m. You can well identify the wedge with an angle 30 degree at the base is located on a smooth horizontal table. So here there is no friction at this place. This is a smooth, and the block of the same mass slides down the rough inclined surface. So this contact is rough, and the rough inclined surface of the wedge and its velocity relative to the table, that means relative to the ground, is oriented at an angle of 60 degree, and this 60 degree is made with the horizontal, and it is equal to v naught, or its magnitude and its direction, both with respect to ground is given. Velocity of the block, find the magnitude and direction of the momentum of the block wedge system, as well as the friction force between the block and the wedge. I would like to do it first, but no, I need to find out the magnitude and direction of the momentum of the block wedge system first. So what can be done about it? To find out the momentum of the block and the wedge system, perhaps I need to find out the velocities of block. Velocity of block is given, so my task is left to find the velocity of the wedge. And how can I do this? There is the only way, I think, using the principle of superposition of velocities, and so that I can write here that velocity of block equal to velocity of block with respect to wedge plus velocity of wedge. I can use this relation, and as given, velocity of the block is v naught and it is at angle 60 degree with the horizontal. So it will have two components, and velocity of block with respect to wedge is not given. Let's call it v relative, but its direction is known and it is at an angle 30 degree with the horizontal. You can see here the velocity of wedge, velocity of block with respect to wedge, and wedge, I can see, let me guess, its velocity should be in this direction, because I think I can think also in this manner too. Okay, since the block velocity vector is directed steeper than the inclined edge of the wedge, so it is clear to me that the wedge is moving to the right, but I don't know about the rest of the people, so I'm going to solve it. And so I can break the v naught into components, and so this component is going to be v naught by 2 cos 60, and this will be to root 3 upon 2 v naught, and these two must be same. This thing and this thing must be same. So this is basically v relative sine 30 degree. That means v relative upon 2 is equal to root 3 v naught by 2. That means I get v relative is equal to root 3 v naught. That means this component is root 3 v naught multiplied by cos 30 degree, root 3 v naught multiplied by cos 30 degree, that is root 3 by 2, so that its value becomes 3 by 2 v naught. And I guess a 3 v naught in this direction and VW in this direction, both are giving me the velocity V0 by 2 in this direction. So V0 was right. I was correct about the velocity of the wedge, and this value I get as V0 because 3 by 2 V0 towards right and plus V0 by 2 towards left gives me the velocity of wedge, that is V0. So wedge velocity is simply V0. I got all of them. And now I can find the momentum of the wedge block system, and to do so I'm going to write down things again. That is velocity of the block in horizontal direction. First I am going to take care of horizontal direction. Velocity is in horizontal direction, and velocity of block in horizontal direction is V0 by 2, so its momentum will be mv0 by 2, and horizontal component of the velocity of the wedge is V0, so its momentum is going to be mv0 towards right. And so I get the total value equal to mv0 by 2 towards right in horizontal direction, and in vertical direction only the block has got the velocity, and that velocity is root 3 v0 by 2, so its momentum can be m or its momentum I should like to write like root 3 m v0 by 2. So and that means momentum of the total momentum of the wedge block system is mv0 by 2 in horizontal direction towards right, and root 3 by 2 mv0 in vertically downward direction, and that means the momentum of the wedge block system is mv0, making an angle 60 degree with the horizontal, because if the total momentum of the wedge block system is mv0 making an angle 60 degree horizontal, its horizontal component will be simply cos 60, that means mv0 by half, and this is sin 60, and that's all. I found out the linear momentum of the wedge block system. Now what? Now I need to find out the friction force acting on the block, and since block is moving with constant velocity, its acceleration will be 0, and friction will act along the incline, and along the incline another force is acting, that is mg sine 30 degree. So and it's moving with constant velocity in whatever direction, so the forces will be balanced on it. It has got no acceleration, so forces will be balanced on it in any direction. So the friction is in this case is mg sine 30 degree, that is half mg, and that's the answer. Thank you for watching.